Hey, Year 11. We're starting a new topic today, which is networks. And we're starting with 9b, and the title for 9b is What is a Graph? What it means by graph is these sort of things here. So they can be called graphs or networks, and you'll see that there's a whole heap of different ones, and they're just like sort of big patterns. Some look super complicated, some are a bit smaller and less complicated. But before we start like trying to answer questions about these sort of things, and there's an example down here as well, um, let's kind of go over some of the language that is going to be used. Because if you don't know the language, you're not going to be able to answer the questions. So these words here, they're going to pop up heaps. So let's just go over them and make sure we know what they mean exactly. All right, so the first one is vertex, or vertices for more than one, for plural. So they're the points that the lines are connecting to. So if we look at our graph or example over here, we can see that the lines are connecting to these points here. So A is a vertex, B is a vertex, and C is a vertex as well. So those three things are vertexes. The next thing is edges. Now edges, as it says here, are the lines that connect between the points, or between the vertexes. So each of these lines, you can call that an edge. Okay, so that's an edge, that's an edge, that's an edge, that's an edge. This is a little bit different. We'll talk about that soon. The next thing is loops. Okay, so an edge that connects back to the same vertex. So what we'll see with this one that I pointed out just before, this one goes out of C and it returns back to C and makes a little loop. So that there is a loop. Now each of these vertices, they have a different degree, which we'll talk about here. So the degree of a vertex is the number of edges that connect to the vertex, and it can be shown as something like that. So if we look at A, do we see how that has 1, 2, 3 edges attached to it? That means the degree of A would be 3. So I can write that one in there. Same thing with B. If we have a look at B, we can see that there's 1, 2, 3 edges connecting into it. So that would have a degree of 3. With C, we've got 1 going in, 2 going in, another one going in there, and even though it's the same one, another one sort of going in there. So this one, C, actually has a degree of 4. Let's go down to our example here. Actually, I forgot about these two. So if a vertex has an odd degree, it's known as an odd vertex. If a vertex has an even degree, it's known as an even vertex. So you might be asked about that briefly in the questions that we're going to do soon. But let's look at our first example here. And we'll just do this one as part of the video. So we've got our graph or our network here. We can see there's a whole heap of vertices, there's a whole heap of edges as well. Let's just go through this list of questions and see if we can answer them. So, how many vertices? The vertices are these points, remember? So we've got 1, 2, 3, 4, 5 vertices. So let's write our answer down there. We've got 5. The next one, how many edges? Remember, the edges are just the lines that connect the vertices together. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. The last one's a loop. We have 8 edges. Next thing, how many loops? We can see that we've only got one that goes out of the same vertex and back into the same one. So we've got one loop. Now degree, remember that means how many edges connect into a vertex. So we want the degree of B. B's here. So we've got 1, 2, 3 lines or edges connecting. So the degree of B is 3. We want the degree of C. 1's going in, 2's going in, 3, 4. Even though they're the same one, that still counts twice because it's connected there twice. So it connects once, twice, 3 times, 4 times. So the degree of C is 4. All right, now, how many odd vertices and how many even vertices? What I might do to kind of make this a little bit easier is just write down how many, or the degree of each of these vertices. So A has 1, 2, 3, 4 connected. B has 3. C has 4. D has 3. And E has 2. Okay, so how many odd vertices do we have? That one's odd as well, so there's 2. How many even vertices do we have? Even, even, even. So we've got 3. And that's it, we are done. So this example here is pretty much the same as all the other questions I'm going to get you to do for this exercise. Just to get us kind of familiar with these graphs or networks and the different words that are involved. Okay, so if you've got any questions, please let me know.